All right, this video is for transformations of functions. This is actually for part 2, which we're going to do non-rigid transformations. And what that means is non-rigid refers to the fact that it will not retain the same shape. So like the U shape, it might get to be a wider U shape, or it might get to be a skinny U shape. In other words, it's not going to be rigid. It's not like I could just grab the shape and just move it somewhere. Everything we did prior to this is just taking the shape and sliding it around the picture, or maybe flipping it over a line, but it still kept the same width or the same shape. All right, so in order to get started, we're doing y equals x squared. So I'm going to take the x value and I'm going to imagine squaring that. So if you take a -3 and square it, that means negative times negative, which actually makes positive 9. -2 squared is positive 4. -1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So those are our values. Notice that squaring a negative does not keep it negative. It actually makes it positive. So notice that I have mentioned over here, it says you will need to memorize this basic graph. Okay, so when we talk about what does a basic graph of x squared looks like, hopefully you do already remember that it's U-shaped and that it has its start at 0, 0. So this graph is going to have its start at 0, 0, so that point is already there. From this point on, we're actually going to graph -1, 1, and then +1, 1. So if I go -1, 1, I'm going to go out from the start point, up 1. I'm going to come back over to the start point, up 2. Or excuse me, up 1 again on the other side. So 1, 1, -1, 1. Then I'm going to come from the start point over 2, up 4, over 2, up 4. Over 3 from the start point, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Come backwards, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. So once I actually get those precise points on the graph, I have a nice smooth graph. Obviously, my board is not aligned perfectly, but I should be able to draw a parabola that comes down. It has this characteristic U shape, and that goes through those points. When I say memorize this basic value, this is the one you need to know. We're going to go over, always go over 1 unit. Always over 1 unit, both directions, because this is U-shaped, so it's very symmetrical. And then to go to the basic graph, you're going to go up 1. So it's always over 1, and then it's going to go up whatever amount of things that you're doing. This is x squared, so that's basically like 1x squared, so we're going to go up 1. When that changes to a 2, we're going to actually go up 2 because we're going to go up twice as fast as normal. So please, please, please keep in mind the basic. What I really want you to know is that we're going to come over 1, up 1. Backwards 1, up 1. That is a key feature to kind of memorize. Let's talk about 2x squared. So we're going to put -3 in here for x, square it, then times the answer times 2. That's what I have to do. I have to square a number first, then times it by 2. -3 squared is -3 times -3, 9. Double that is 18. -4 squared is 4, doubled is 8. -1 squared is 1, doubled is 2. 0 squared obviously is 0. Even if you times it by 2, it's still 0. It's going to be 2. It's going to be 8. It's going to be 16. If you haven't figured it out, from 0 down and from 0 up, those points are always the same y value. It's because they're symmetrical with respect to the x-axis or the y-axis. So, just going to refresh your memory real quick. I went over 1, up 1 for the basic graph. Okay, then I went over 2, up 4 for the basic graph. Okay, I'm not graphing those points yet, so I want you to keep in mind. Remember how I've kind of sort of said I want you to kind of keep in mind we want to make sure that we remember the basic graph. Now I'm actually going to go in green and I'm going to graph y equals 2x x squared. So I'm going to start at 0, 0, same start point. And I'm going to go over 1, up 2. Over 1, up 2. Okay? Did you notice that we went up 2 on the first movement? The first movement on a basic graph is over 1, up 1. But the basic movement for 2x squared is over 1, up 2. Okay? So basically we went up twice as fast as a normal graph. Over 2, up 8. Let's see, 4, 5, 6, 7, 8. And of course over here would be the same matching point, 8. Then I don't have enough room to put this one on the graph, but it would be over 3, up 18, which I don't have enough room to go up to 18. But what do you notice about the graph for 2x squared? Okay. Did you happen to notice that it's skinnier? Sometimes we say skinny. It almost looks like someone's up here, and I can't draw a hand, but it's almost like I wish I had a hand up here, and we're going to stretch it upward, and it kind of pulls it in together, so it's closer to the y-axis. So again, that graph grew twice as fast. From the start point, it went over 1, always go over 1. And this one went up 2. So it went up twice as fast, and that's how I knew it was going to be skinny, because it's going to be closer to the x-axis. And it does that on both sides. So again, that first movement is a key feature of the graph. Next, 1/2 x squared. So this one's going to grow half as fast as the normal graph. So just for reference, I'm going to put the original points on here. Remember, over 1, up 1, original points. We always want you to keep in mind over 1 the other way and up 1. Okay, I'm going to go over 2, up 4, over 2, up 4. I'm just putting those on here because I want to make sure that you remember the basic shape of the original graph. And then we're trying to see how does the new graph change from that one. Well, the change is going to be with the 1/2. So basically, I'm going to square the number and take half of it. What's -4 squared? What's -4 times -4, which is 16? Half of 16 is +8. All right, -3 squared, 9. What's half of 9? I think it's 4.5, and we can actually graph 4.5 pretty closely. All right, -2 squared is 4. Half of 4 is 2. -1 squared is 1. 1 times a half is a half. 0 still 0. This is going to be a half. This is going to be 2. This is going to be 4.5. And this is going to be 8. Again, the first movement, I start at 0, 0. Okay? So I'm always going to have the same start point as long as it doesn't have plus or minus anything. Then I'm going to come over 1, but up halfway. Did you notice that? This time I only came up halfway. Then I'm going to come over 2 units and up 2. Over 2, up 2. Then over 3, up 1, 2, 3, 4 and a half. Over 3 and up 1, 2, 3, 4 and a half. Then I'm going to come over 4, up 1, 2, 3, 4, 5, 6, 7, 8. And backwards, 8. Now let's draw that new shape. What happened when I put a half in there? Basically, this graph looked like it grew up half as fast, which makes it a much wider graph. Okay? It makes it much wider. The key movement is right here. As soon as this became 1/2, I come over 1, but I go up halfway. So see, that 1/2 kind of tells you on the vertical how high it's going to go to start with. This graph looks like an elephant sat down on it and it whoosh, pushed it outward. So this is what we call a much wider graph. It's not skinny at all because it goes outward farther than the original x squared graph. All right, so now let's see if we can put those together. I'm going to put these all on the same graph, and you could do this as an investigation, but we're going to do it. I'm going to do it right here. I'm going to move this graph up here where I can work with it just a little bit. I want to put x squared on here, so if I do that, over 1 up 1. So that's x squared, over 2 up 4. And that's about all I can do. I don't think I have where I've moved my graph. Okay, so that's going to be the first one. All right, the second one says 1/2 x squared. Well, I just practiced that one, so I'm going to come over 1 up halfway. Okay, so that graph's going to come out like that. That's a wider graph. What do we think is going to happen when we do 1/4? Well, I'm going to come over 1. I always go out 1, but this time I'm only going to go 1/4 of the way. That's only half of where I was at before. That's going to end up being even wider. Over and up 1/4. It's going to be even wider. Okay. What do we think might happen if we get to 1/8? Oh my gosh. Come over 1. Always come over 1. But I'm only going up 1/8. Wow. It's going to end up being even what? Wider. So this is 1/8 x squared. This is 1/4 x squared. This is 1/2 x squared. And this one here becomes what? Just original 1x squared. So what happens is, what effect does having a smaller and smaller a value have, which is the number in front of x squared? So what does it make it do? It makes it get wider and wider. Smaller and smaller a value. So when I go from 1 to 1/2, it got wider. To 1/4, it got wider. To 1/8, it got wider and wider and wider. Sometimes we say the graph shrunk. Okay, it shrunk. It's like you push down on it, almost like an elephant. You push down on it, bulges it out. And so we call that, we're going to refer to this as stretch and shrink. And so this graph has a shrunk. It's shrunk down. It is not coming up nearly as fast as it should, and it's holding it back. All right, number 14. Clear all of your graphs. So if you did put this in your calculator so you could see those for yourself, of course I'm just sketching. Put all of these on the graph one time as much as you can and go. Okay. I'm going to pull this graph over here so I can work with it. All right, here we go. So it says 1x squared. So I know that one's going to be at 0, 0. No, it goes over 1, up 1, because that's the basic graph. Remember, I said memorize that. Over 1, up 1. Always over 1. Over 2, up 4. Over 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I do have enough room to put those on there. So now I have this one. Okay, miss it just a little bit, but that's 1x squared. Now I'm going to pick up a different color, and I'm going to do 2x squared, which we actually investigated, very like one of the first ones. So when you go 2x squared, we're going to be going up twice as fast. This graph is going to grow twice as fast. So I'm going to go over 1, but I'm going to go up what? 2, right? My first move. That's where the 2 comes in, always over 1. So I go over 1 and up 2. So now I have some points, and I can kind of sketch that in there. I could do more points if I wanted to, but I'm just trying to get an idea. So that one became 2x squared. Now what happens if we change it to 3x squared? Well, we're still going to be starting at the center, 0, 0. And I'm going to come over 1. Remember, always over 1. But this time I'm going to go up 3. So I'm going to go up 3. So right away, do you see that we actually have an even skinnier graph? That would be 3x squared. Of course, I'm sketching these. I'm not doing a precise graph. But where would I go if it says 4x squared? So remember, it's almost like you're grabbing this graph and you're stretching it upward. Okay? So I'm going to start at 0, 0. Now it's a 4. So I'm going to go over 1, always over 1. And this time I'm going to go up 4. Over 1 and up 4. So now I'm even skinnier than I was before. So that would be 4x squared. So what happens? I know those are not perfect graphs, but they're sketches. So what effect does having a larger and larger a value have on the graph of x squared? Well, it ends up getting what? Skinnier and skinnier. Okay, it gets skinnier and skinnier. We call this vertical stretch. And what that means is it's like you grabbed it and you stretched it up. Almost like I remember a toy I had. It was called Stretch Armstrong. It had legs. You could grab the legs and you could stretch them up. And so that's called vertical stretch. So it looks like you're grabbing the arms of the graph, almost like you're coming in here and you're grabbing the arms, and then you stretch it up. And as you stretch it up, you get skinnier and skinnier. Okay, so that's what we call vertical stretch. When the number is bigger than 1, it stretches. It vertically stretches. When the number is less than 1, okay, oops, skip 1. This is actually vertical shrink, which I did use the word shrink, but I said shrunk, but it's called vertical shrink. So it's like vertically you shrink it or you push it back down. All right, so vertical stretch, vertical shrink. All right. I now need, so our focus has been on x squared. Now I want to put a little bit of focus on root x, which is actually the function that we're going to be working with. So when it talks about y equals square root of x, that's actually going to be part of Unit 4. But if you'll remember, transformation of either function is exactly the same except for the shape of the graph. So just to review, the shape of x squared is u. So x squared is a u. Square root of x, though, starts and looks like the top of an R. It's half of a sideways parabola. Okay, so if I grab this graph and move it up here where I can work with it a little bit better, first thing I want to do is I'm going to imagine, I probably should have done an x and y table, but I know it starts at 0, 0. And if I were to make myself a table, okay, x and then square root of x, 0, take the square root of 0, and that gives me 0. Okay, what if I put a 1 in there? Well, the square root of 1 is still 1, right? 2 now is not going to be an even number because the square root of 2 is not even. I think it turns out to be like 1.4. 3, the square root of 3, that turns out to be like 1.7 approximately. Okay, but now 4 is a perfect square. What's the square root of 4? 2. So I can put some nice points on this graph, and I think I will. So if I do a 4, the square root of 4 turns out to be exactly 2. What if I put 9 on there? Well, I'd have to do square root of 9, put 9 in the square root. Square root of 9 turns out to be 3. So I actually do end up with at least a few perfect points that I can use to make a pretty neat looking graph. So here I go. I'm going to go over 1, up 1. Did you catch that? We went over 1, up 1. So even on the square root graph, we still have the over 1, up 1 as our first movement of our basic, simplest, easiest graph. Then I'm going to go over 4, up 2. And over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have 9. But even if I went to 9, it'd be way up here. So I just have enough points that I can kind of get the general shape of the graph. And that would be the square root graph. Now, this is actually saying, what do you think happens if I make it 1/2 the square root of x? I'm hoping that you're thinking, oh, just like that other one. It's only going to grow up half as fast. It's going to grow up half as fast. So let's just see if we can figure this out. It's going to grow up half as fast. I've said that 3 times now. So we always go over 1 from the start point. We're always going to go over 1, but I'm only going to go up halfway. Oh, man. Halfway. So let's go over 4 and up halfway. Well, half of that's... So now I have a graph that looks like somebody sat on it because they shrunk it down. So it looks even flatter than normal. Oh, I didn't do the rest of them, did I? Let me see. What else am I doing? 1/4. That's 0.25. Is 0.25 the same thing as 1/4 times the square root of x? So if I come over here, I'm going to always go over 1. You always go over 1, but this time I'm going to go 1/4 of the way. And I'm going to go 1/4 of that, which would be half. So actually, my graph looks even what? Even flatter. So they get flatter and what? Flatter close to the x-axis. Okay, flatter and flatter close to the x-axis. And again, we're going to call that vertically. This thing didn't stretch up. This thing did what? This thing shrunk. It looks like an elephant was sitting on it. And if an elephant's sitting on it and it's a spring, then it's basically like it's pushing down on it, and it makes it even flatter and even flatter because it's not growing up vertically fast at all. Okay, so this is just seeing how So we change it. So numbers that are smaller than 1 are making ours shrink down farther and farther down. Last one. Wonder if we can predict what's going to happen here. Okay. Grab my graph, put it over here where I can see it. Just to remember those points, I think from the square root of x graph. So if I did x, square root of x, I know 0, and the square root of 0 is 0. Okay. And a 1, the square root of 1 is still 1. Those are nice points. 2 is not perfect square, 3 is not perfect square, but square root of 4. So if I put a 4, I get a 2. And again, if I have a room for 9, square root of 9 actually gives me a what? 3. So I do have some points. Again, 0, 0. Over 1, up 1. Okay. Over 2, or excuse me, over 4, up 2. And that's as much as we have room for because I didn't have enough graph, or didn't put more graph. That's the basic square root of x graph. Now what's going to happen when it says 2x? Now, is this going to be vertically shrank like the last one, or vertically stretched upward? This one's vertically stretched. That 2 is going to come into play. We always go over 1, but now we're going to go up twice as fast. I'm going to come over to 4, and I'm going to go up twice as high. Boom. And that gives me a much what? It still has the same basic R shape, but it's stretched upward. Okay. What about 3 square root of x? 3 square root of x. I'm going to start at the center. I'm going to always come over 1. Then I'm going to come up 1, 2, 3 times as fast. Come over to 4. Go up 2, go up all the way up to here. That's 3 times as fast. So this is 3 times the square root of x. This one was 2 times the square root of x. And of course this one is just the regular 1 square root of x. So what effect does having a larger and larger a value have on the graph of square root of x? Well, it looks like it gets what? Taller and taller. This one is what we call, it is vertically stretched, which means it looks like it was pulled up. Okay. All right. Does everybody kind of get the idea? So this is our observations that we hopefully can see from changing the a value, which is going to shrink and shrink it. Now, I do readily admit 1 through 8 is going to ask you to do lots of transformations. And we're going to try to do these without a calculator. So I want to do the first 2, and then I want you to try the next 6. Now, I'm going to tell you ahead of time, these are meant to be deliberately challenging. So I'm going to take it one thing at a time. This is a -1 on the outside. Take your sticky. What do numbers on the outside make it do? Well, they make it go up and down, same as the number. So that's not going to be, that's -1. So it's not going to go up, it's actually going to go down 1. Okay, so that's my first observation. Then I notice that I have a number on the inside. Okay, the +2 is on the inside with x. That's on my second bullet on my sticky. What does +2 do? Well, that makes it go left and right, but opposite the number. So instead of going right to +2, no, this thing's going to end up going what? Left to -2. It's going to go left 2. The last thing I'm noticing is, we have a factor of 1/2 in the very front. That's my a value. Okay, so that's my a value. So that tells me, is it going to vertically stretch or is it going to vertically shrink? And I realize right now I should have done something. All right. The back of your sticky. Let's pause right now. You have a sticky that I gave you that has 4 bullets on the front. Now we're going to actually put 2 bullets on the back. Okay, so this is, if you want to use an extra sticky and you have one, you're welcome to use your sticky, another sticky, but if you want to use the same one, just go to the back. So on the back of the sticky note, okay, here's what we're going to do. If the a value in front, okay, is greater than 1, okay, it means greater than 1, like 2 x squared. Okay, like 2, 3, 4. Okay. All right. then you're going to vertically what? Not shrink, but we're going to stretch it up. Okay, it's vertically stretched upward. What if the A value in front is less than 1? Okay, not negatives, but just less than 1. Okay, that means like 1/2 and 1/4 and 1/8, like we were practicing. Okay, those kinds of things. Then this would actually be vertically what? It would be vertically shrunk. Okay, it's going to look lower. Well, I don't know. Vertically shrunk. Yeah, it's going to get wider or lower. Wider or lower. So, I got to put that in. This one's going to be either skinny or taller. Skinny on the U's, taller on the R's. The R is going to look really tall. There's a glitch there. This is either going to get wider graphs or it's going to get much lower, like it looks like it barely moves. That's what I mean by that. Okay, so here we go. Let's go back to the graph. So 1/2 is my A value, which means it's going to shrink. This thing is not going to grow up nearly as fast as it should. So now let's see if I can put all 3 of those changes together. So first of all, let me locate the new point. What's going to go left 2, so that takes me to -2. Don't stop there. Now I'm going to go down 1. So I went left 2 and down 1. Now I'm actually at the point -2, 1. So that actually gives me -2, 1, and that's actually the location of my new vertex. Okay. Now I'm going to shrink it. And so instead of coming over and up 1 full unit, I'm going to come over and up 1/2. So this thing's going to get wider than normal. So I know it's kind of hard to do. Just sketch something that looks wider than a normal U. Okay. So this one should make it look wider. Number 2. Again, I should have actually 3 things that happen. What happens when I see +4 at the end? That's a number on the outside. Okay, it's not inside parentheses, it's not inside under a bar, it's a number on the outside, and it goes up or down, same as the number, so it's going to go up to +4. All right, there is no number on the inside. You could rewrite this as -2 x plus nothing squared plus 4. So basically this thing does not move left or right. Okay, does not move left or right. So no left or right. Okay, there are no parentheses. I showed them what it would look like if. Now, the negative makes it do something. What does the negative make it do? Well, that's going to make this graph flip down. Okay, so what used to go up is now going to flip opposite. It's almost like we're going to reflect it across the x-axis, which is exactly what I mean to do. And then the 2 right here, the 2, don't look at the negative, just the 2, that's going to make it vertically stretch. So it's going to vertically stretch, and in this case, it's going to actually look much skinnier. I guess I'll say skinnier. See if we can put all that together. First thing I want to do is I'll say, well, this thing's going to go up 4, but it's not going to go left or right any. So the vertex is actually where? 0 and up 4. Now I have to make it flip down. So remember when I said it's going to stretch. So instead of coming over 1 and up 2, since I have to go down, I'm going over 1 and down 2. Both sides, over 1 and down 2. And by George, I think that's it. It does look much skinnier than normal. It is flipped down and it's shifted up. All right, that's at least got you started. You are assigned to do the next 6. You can confirm with Desmos, but you need to try these by looking at the individual things that make this transform.